Hello all. So today's class will begin the fourth module. So the module 4 is on generating functions and recurrence relations. And in generating functions, we'll be mainly seeing what is an ordinary generating function and an exponential generating function, and how to use these functions to find out various uh, solution to various combinatorial problems. And in the second part of the module, we'll be looking at recurrence relation, how to solve for a recurrence relation, and some of the problems where uh, we solve using the technique of recurrence relation. So that is module 4. So in today's class, we'll begin with generating function. So first we are going to look at what is called an ordinary generating function. So consider a sequence of numbers. So let me denote it by the sequence AR. So let AR be a sequence where the terms are A0, A1, A2, A3, etc., AR, etc. Be a sequence of numbers. Then the generating function or the ordinary generating function corresponding to this sequence is defined as a series which is having coefficients as these numbers. So that is series of the form a0 plus a1x plus a2x square plus a3x cube. So given a sequence of numbers, then the usual power series where the coefficients are these sequence of numbers is called an ordinary generating function. So the ordinary generating function for the sequence AR is defined to be the power series. So we denote it by A of x. So A of x is equal to summation r equal to 0 to infinity AR x bar r. So that is equal to A0 plus A1x plus A2x square plus etc. So this is the meaning of an ordinary generating function. Now if you have two generating functions a of x and b of x, provided all the coefficients are equal, then in that case the two generating functions are equal. So two generating functions a of x and b of x for the sequences AR and BR are respectively are equal if and only if AI is equal to BI for each I belongs to star. So that is here for 0, 1 n together with 0. Okay. So that is the set 0, 1, 2, 3 up to infinity. Now, if I have two generating functions, suppose I have a of x equal to summation ar x bar r, and so this is r equal to 0 to infinity, and if I have b of x equal to summation r equal to 0 to infinity br x raised to r, then let us define the sum and the product of these generating functions. So the sum ax plus bx and product a of x into b of x are defined by, so that will be a series of the form. So a of x plus b of x will be c naught plus c1x plus c2 x square plus etc. And a of x into b of x will be equal to d naught plus d1x plus d2x square plus etc. where here CR will be equal to AR plus BR, and when you take dr is equal to A naught BR plus A1 BR minus 1 plus etc. Plus AR B naught. So that is the value of CR and DR. So here R varies from 0, 1, 2 to infinity, and here also R value varies from 0, 1, 2 up to infinity. Now let us look at what is called the generalized binomial expansion. Now here when you look into problems, you are going to work with series. So we will look at what is the generalized binomial expansion. Now for every alpha belongs to R, so the expansion of 1 plus or minus x whole raised to alpha is given by summation r equal to 0 to infinity alpha CR into plus or minus x raised to r. So this is called the generalized binomial expansion. So when you expand it, you will get 1 plus or minus alpha x plus alpha into alpha minus 1 by 2 factorial x square, then plus or minus alpha into alpha minus 1 into alpha minus 2 by 3 factorial x cube plus etc. So the general term will be minus 1 raised to r alpha into alpha minus 1 up to alpha minus r plus 1 x raised to r by r factorial plus etc. So using this we can obtain the expansion for the series like, so if you have 1 by 1 minus x, so that will be 1 minus x whole raised to minus 1. So as you know, the expansion is 1 plus x square plus x cube plus etc. So that's a geometric series, and you want 1 by 1 minus x whole square, so we'll get 1 minus x whole raised to minus 2, so that has the expansion 1 plus 2x plus 3x square plus 4x cube plus etc. And 1 by 1 minus x whole power n has the expansion 1 plus nx plus n into n minus n into n plus 1 by 2 factorial x square, then n into n plus 1 into n plus 2 by 3 factorial x cube plus etc. So that is equal to summation r equal to 0 to infinity n plus r minus 1 cr x raised to r for each n belongs to n. So these are a few results using the generalized binomial expansion. Now let us look at a few examples of generating functions. So if you have a sequence AR which is defined as 1, if R is equal to N and 0 otherwise, that means if you have AR equal to അതായത് nth term മാത്രം 1, ബാക്കി എല്ലാ termsഉം 0. So we will have all except the nth term to be 0. Then the generating function of AR will be given by അപ്പോൾ നമ്മൾ A0 0 ആവും, A1 0 ആവും, A2 0 ആവും. Only an x bar n will come, remaining will be 0. So that will be n 1 into an in the value 1 ആണ്, 1 x bar n. So that will be equal to x bar n. So given any sequence, അപ്പോൾ നമ്മൾ ഈ ഇതിനകത്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക AR x bar r, where r is equal to 0 to infinity, that will give the corresponding generating function. Now if you want the generating function of the sequence given by nc0, nc1, nc2 etc, ncn, then all the remaining terms 0, then the corresponding generating function is, so that will be equal to summation r equal to 0 to n varum ncr x bar r. So this will be the expansion of 1 plus x whole bar. 1 plus x whole bar and the expansion എടുക്കുമ്പോൾ നമുക്ക് കിട്ടുന്ന സീരീസ് ആണ്. So the generating function corresponding to this will be 1 plus x whole bar n. And the next example is, so the generating function of sequence. So if you have the sequence with all the terms as 1, so then the generating function will be equal to summation r equal to 0 to infinity 1 into x bar r. So that is summation r equal to 0 to infinity x bar r. So that will be, this is a geometric series, so 1 by 1 minus x varum. And again similar to this, so the generating function of the sequence. So if you have the sequence as 1k, k square, k cube, etc, the generating function will be given by 1 plus kx plus k square x square plus k cube x cube plus etc. So this is again in the form of geometric series, so 1 by 1 minus kx. And similarly, if you have the sequence 1, 2, 3, 4, 5, extra n, then the corresponding generating function will be 1 plus